Hi everybody, welcome back to the course. In the previous weeks, you have learned to define infrastructure systems as complex socio-technical systems, and you have seen how today's large-scale infrastructure networks evolved over decades and even centuries, driven by emerging needs and technologies. Conceptually, we can separate the physical network and the multi-actor network, but in practice, they are obviously inseparable. Like two sides of a coin, they are both part of one and the same infrasystem. Now, if we diagnose a problem in one of our infrastructures, it is clearly impossible or very impractical to include the entire system in our problem definition. We have to come up with a meaningful system delineation for the problem at hand. That is quite a challenge, as infrasystems are characterized by fuzzy borders, as you will see in this week's course modules. A meaningful system delineation for a given problem entails that you focus on the relevant geographical scale level, that you focus on the relevant time constant, on the relevant actors, and on the relevant institutions. For instance, are you dealing with a problem that requires intervention by a supranational authority? Or is it something that can be solved at the local level? Are you dealing with a problem in infrastructure's operation? Or is it concerned with securing future infrastructure performance over a longer time scale of perhaps several decades? And are you dealing with a problem that originates within the same infrasystem? Or is its root cause originating from another infrasystem? It may be disconcerting to realize how interdependent our infrastructure systems are. Without electricity, mobile telecommunications will break down. Without telecommunications, the electricity infrastructure itself will stop functioning properly. The interdependencies and interactions between different infrastructures explain why it is so difficult to restore basic services after natural disasters such as hurricanes, floods, and earthquakes. We are, in fact, dealing with a system of systems in which a local fault, if it cannot be contained, may propagate across national borders and across different infrastructure sectors. This week, we will see why interconnected infrastructure systems were brought into being. Once you understand the mechanisms and driving forces, you may be able to judge for yourself whether or not the benefits of network expansion and interconnection outweigh the risks and vulnerabilities of interconnection. You will also see that the borders between different infrasystems are becoming only fuzzier as infrasystems are acquiring new functionalities. You can now access the internet through your TV cable, through your mobile phone, through your laptop, and through your PC, with a choice of fixed and wireless networks to hook onto. This is only possible because the operators of all these different multifunctional communication networks agreed on interoperability standards. Also, within monofunctional infrastructure systems, such as railway systems and electricity infrastructure, interconnectivity and interoperability standards are key to ensuring the smooth functioning of interconnected multinational infrastructure systems. In other words, this week's course material will show you the increasing complexity of infrastructure systems caused by expansion and interconnection of infrastructure systems across national borders and across the borders between infrastructure sectors. Thank you for your attention.